Okay, so we are going to start talking about Chapter 7 stuff now. Chapter 7 is integers, scientific notation. So essentially, overall, Chapter 7 is about how to compute with really big numbers or how to compute with really small numbers. So we're going to talk about a couple different ways of expressing really, really big numbers and really, really small numbers so that they're easier to do math with. Rather than trying to have to do like 1,600,000 times 1,200,000 with all those zeros, we're going to talk about a couple different ways of sort of simplifying the math for those throughout this whole chapter. So what we're going to start talking about today is just exponents in general. What exponents are, how we can use them, and a couple special cases. So what is an exponent? What is an exponent? Like that right there, 5 to the third. What is that? Means 5 3 times, right? So you multiply 5 times itself 3 times. So does that give you 15? No, you do not multiply the numbers times each other. You multiply 5 3 times. So 5 times 5 times 5 would be what? 125. Good. 5 times 5 is 25. 25 times 5 is 125. What happens if we have an exponent of 0 or a negative exponent? These are the two things we're going to talk about today. So what happens if your exponent is 0, and what happens if your exponent is negative? And a lot of you guys should have seen 0 exponents before, but we maybe haven't really dealt with negative exponents, so we'll talk about that today. All right, so here are our two. This is just how the book basically sums it up. So you guys have this on your slides. You don't need to write it down, but this is just to sum up what we're going to be talking about today. So this is if you have a 0 exponent, and this is if you have a negative exponent. All right, so any non-zero number, so anything really except for 0, raised to the power of 0 equals 1. Anything. Does anyone know why? Brendan?
Because you basically go 5 times 5.
Yeah, that's basically right. So what you're saying is if you, and I think we did this before, if you have 5 to the 4th power, what is that really, how else could you write that? Okay, so then we said, well, if I've got 5 to the 3rd power, what do I have to do? I have to do what with one of these 5s? Take one away. How do you take away a 5 if it's a multiplication problem? Divide. So we divide by 5 here, and then what happens to this one? Those go away, and that's where we get 5 times 5 times 5. So then how do I get to 5 to the 2nd? Divide again, which gives me 5 times 5. And then how do I get to 5 to the 1st? Divide again, and then I get just 5. And then how do I get to 5 to the 0? Divide again, and what's anything divided by itself? 1. So that's where that comes from. That's why anything to the 0 power is 1, because essentially this is like 200 divided by 200, 3 divided by 3, or 5 divided by 5. So all of those things to the 0 power will always give you 1. All right, they don't give you 0, they equal 1. Anything to the 0 power is 1. Okay, what happens in a negative exponent? What do you see up here? What do you see happening? What is your initial problem? 5 to the negative 4th power. What happens over here? It's equivalent to what? 1 over 5 to the 4th power. So what did you do? Or what did I do? Because I guess I wrote this. But what did you do? You make it, I fractionized it? Okay, I fractionized it. Where did I put the 5? In the denominator. Okay, what happened to the exponent? It became positive. And then what do you put on top? 1. It's just 1 over whatever you have. So for example, if I gave you this, I said 8 to the negative 3rd, how would you write that? 1 over 8 to the, okay. Just like you cannot leave a variable negative, you cannot leave an exponent negative. So this would be considered an incorrect answer. It's not simplified. So you've got to simplify it. It's always going to be 1 on top, and then it's just whatever your base was, but your exponent now, instead of being negative, becomes positive. Yeah?
So like we can't write 8 to the power, like we can't write that. We need to put it in the fraction.
Yes, because this takes away the negative sign. You're moving it into the denominator, which takes it into the negative sign. So then again, if you had something like 7 to the negative 6th, what would that give you? 1 over 7 to the positive 6. Okay? So by shifting it to the denominator, that takes the exponent from being negative to a positive, and your numerator is always 1. All right? Unless you have another negative exponent on the bottom, which we'll look at in a second. Okay? Could I simplify this anymore? This is 1 over what? 8 times 8 times... Okay, I don't know 64 times 8 off the top of my head. I know, hang on. 640 minus 128 would be, wait, don't tell me. 5, 12? Is that right? Oh man, that took too long. I need to work my brain out more. Okay, so it's 512. So it's equals 1 over 512. So if you want something fully simplified, this is fully simplified. There's nothing left to do. Okay? 1 over 512. So again, if it's a negative exponent, this is uncomfortable. You can't leave it like that because it doesn't really make sense. You have to put it into the denominator. Numerator is 1, and then that makes the negative exponent go away. All right, so how would I simplify this? A. Ollie? Good, and then what? Good, 1 over 8. Perfect. All right, 1 over 8. What about this one, C? Same thing? What would it look like? It would be, what would be on top? 1. What's the base? Negative 3. And then what's the exponent now? 4. Okay, so the exponent changes. Does your base change? No. So if your base was negative, it stays negative. So that means if I expand that out, what does that look like on the bottom? All right, what's negative 3 times negative 3? 9. And 9 times 9 is 81. Yeah, because this is 9, and this is 9. So 9 times 9 is 81. All right. Could this ever be negative then on the bottom?
Yes.
If what?
If the parentheses were
If the parentheses were gone,
gone.
good. Or what if your exponent was, it could be like 3 to the, negative 3 to the what power? What would make it negative? 5? 3? Any odd number. Good, if your exponent were any odd number. Okay, or like Brendan said, if there were no parentheses, because if there are no parentheses, your answer is always negative. Okay, so x to the negative 1 for x equals 2. What's the first thing I do? Substitute it in. So this 2 goes here, and it becomes 2 to the negative 1. So then what does that equal? And 2 to the 1 is just 2. Good. 1 over 2, which is just 1/2. Okay, so a negative exponent means that you move it to the bottom. 1 is your numerator, and then that gets rid of the negative sign in front of the exponent. So go ahead and try all of the first 4, and then just do the odds down here. All right, so when we're looking at ones like this, what is really important? If you were going to say, like, what did you have to be really careful with when you were at the boards? Parentheses. Be really careful with parentheses. So, for instance, number 11, because this is in parentheses, I'm going to write this out. And 5z is actually 5 times negative 3 to the negative 2 power. So I do what's in parentheses first, which gives me what? Negative 15. Now that's still in parentheses, which means when I go to get rid of this negative, what does it look like in a fraction form? Negative 15 to the second power. So the negative 2 loses its negative. The exponent loses its negative, but the 15 stays negative. So your answer ends up being what? 225. 15 times 15 is 225. I've noticed something that happens is a lot of people understand that to the second power, like if I do 5 to the second, you know that that's 25 and not 10. But then when I do bigger numbers, people all of a sudden want to say like 30 for this. That's like several people did it. And I honestly think that's your brain's way of being like, I don't know 15 times 15, so I'm just going to go with 30 because I can do that really quickly. Don't get caught in that trap. That's why you have calculators. All right, so just always remember, even if the number's huge, you still have to multiply it by itself, okay? So that's a mistake I see all the time, so just police yourself on that. Be careful with that. Okay, what happens if the negative is already in the denominator? What happens if the negative exponent is already in the denominator? No, we did this. So we did 5 to the negative 4th, and it became 1 over 5 to the 4th. So what do you think we do if it's already negative in the denominator? Diego? Flip it. So if it's negative in the denominator, to get rid of that negative, where do you have to put it? In the numerator. So you literally just flip it to the other side. Now, you don't do anything with the 1. The 1 does not have a negative exponent, so that also stays here. So it becomes 1 times 5 to the 4th, and now there's nothing in the denominator. Okay, so that's it. It's no longer a fraction in this case. All right, 5 to the 4th would be 25 times 25, which is 625. So 625 times 1, which is just 625. Okay, so the 1 does not have a negative exponent. That means it does not move. So when we say flip it, that doesn't mean just flip the fraction. That means just take whatever's negative and move it to the top. All right, and the reason I say that is because a lot of times people just want to flip it and they'll move too much stuff. All right, you only move the thing that has the negative exponent. Brennan? You're only moving the base and the exponent. So this, if the exponent is negative 4.
So you're not moving the 5?
No, that's the base. So you're moving the base and the exponent, but when you move it, what happens to the sign?
Oh, so you're not flipping it?
You're not flipping it, you're moving it. And the reason I say that is because I know in this case, even if you flipped it, it would still give you the same thing because it would be 625 over 1, which is still just 625. The reason I don't want you guys to think that way is because you'll have problems like this, where you've got some stuff in the numerator already. So I don't want you to get in the habit of flipping it. All right, so then how would you do this one? How would you do this one? I almost agree, but not quite.
Negative 4 goes on top.
The negative 4 should become a positive.
Put it over 1.
I don't want to put it over 1. Is it in parentheses? So what does the negative 4 go with? Emily? You have to leave 8 on top, because what does the negative 4 go with? Just the y. There's no parentheses here, which means that this negative 4 doesn't apply to both. It applies to just the y. So I want to move the y to the bottom. So that's going to become y to the positive 4. But does the 8 move? No. So that stays up here on the top. Because the y has the negative exponent. The 8 does not. If there's no exponent, remember, what is the exponent? The imaginary one you can't see. It's always to the power of, if there isn't one, it's always to the power of 1. So the 8 has a 1 exponent, and that 1 is positive. So it stays up here on the top, and then the y has to shift to the bottom. Can you do anything else here? No. If I told you that y equals 3, could you do something? Sure, but I'm not telling you that. All you know is this, so this is all you can do to simplify it. So again, the 8 does not go with the negative 4. If it were in parentheses, would it go with the negative 4? Then you would move the whole thing. But it's not in parentheses, so the only thing that the negative exponent applies to is the y. So if you have like 5 to the times x to the negative 6th, what would this look like?
The
Which moves to the bottom? The x to the 6th. And where does the 5 stay? Up on the top. Okay, now, what about this? Okay, what about this? Which ones move and which ones don't? I can't move it all to the top. Which ones move?
Oh, move the negative ones.
Moves things that have a negative exponent. So in this case, which things have negative exponents? The D and the Z. So does the C move? No, so it will still be where? On top. Does the E move? No, so I've got C to the 3rd, E to the 5th. Oop, not E to the F. E to the 5th. And then on the bottom, what stays on the bottom? Q to the and R to the 4th. Now what happens to the D to the negative 4? Moves to the bottom and becomes what? Good, so it becomes D to the 4th. And then what about the Z? Moves to the top and becomes positive. Okay, so the only stuff that shifts is the stuff with a negative exponent. Everything else stays the same. So every other thing here will stay the same. So the C didn't move, the E didn't move, the Q didn't move, the R didn't move. So really all you did was switch the D and the Z. All right? If it's a negative exponent, it moves. So if it was on the bottom, it goes to the top. If it was on the top, it goes to the bottom. Questions about this one? This looks very complicated. You don't really have to do anything though, because you don't have any numbers, so there's nothing to plug in, so you're done right there. All right, it looks super complicated, it's not. All right, so what would happen in A? What would go on top? The 3 would go on top, and then what would be on the bottom? Y to the 2nd power. All right, the negative goes away when you move it, so that would go to the 2nd power on the bottom. All right, what about B? Bring K up. What happens to the negative 4? What's the exponent of it? 1. So does that move? No, because that's a positive exponent, so that stays the same. So do I have anything on the bottom anymore? No. So what do I have left on the top? Negative 4 times K to the 4th. All right, so again, you only move it if it has a negative exponent, not if it's a negative number, if it has a negative exponent. So what's going to happen down here? What's moving here? Just the x. Is the a moving? Is the y moving? So where is everything? Which means what do I need on the top? A 1. Why? You need to make it a fraction. You need a placeholder. Otherwise, I don't have anything. Okay, so I've got a to the 0, y to the 5th, x to the 3rd. Can I simplify that at all? Yes. There's one thing I can simplify there. Does anyone know what it is? A to the 0. Why? Because anything to the 0 power equals what? 1. So I don't need that. I can make it 1. 1 y to the 5th, x to the 3rd. Do I even need that 1? No, I'm going to leave it there, but you don't need it. Okay? All right, so I would write that down if I were you guys. Again, if I'm writing things down on the board, you should write them down on your notes as well. All right, and then you guys are going to go to your boards and do these 4 I'm going back to this. But you guys should go to your boards. Once you've copied that down, go to your boards and do those 4 practice problems. I will shift to that board in just a minute so you guys can actually see it because I know it's tiny.